Hi, Sune. I'm quite happy that today we're doing this. I'm going to ask you a couple of questions because these questions are what people believe that everyone knows about, but usually nobody knows about, and people take them by granted that, yes, at some point in academia, you get to know it. But I don't think it's like that. It's just like that we will have a lot of classrooms in our bachelor's, and then we get to PhD, and then at some point we start teaching. But most of us has never been trained for a proper lecturing experience, right? And this is kind of even worse when it comes to do research, because I believe people talk about writing a paper together and something, but there are still some skills or some ideas that are missed.
Yeah,
Yeah. So
100%.
so
And
to,
by the way, I've never learned it either.
okay. So now
So so we need to figure it out together, I think.
okay. So let's begin with this. Recently, there was this interview with you from DTU, and I borrowed this line from them because it's kind of interesting as an opening line for today. They say that you are a physicist who explore people's lives and behavior through data from social media and statistics. Well, how did it happen? Like, what does a physicist should be working on social media and like people's behavior? Weren't you supposed to be working on atoms and particles and stuff?
Yeah, I mean, I'm old enough that that there definitely was no topic of computational social science when I started out. And the thing that was closest was that people were beginning to look at networks, right? And
Yeah.
and so in a way, I really wanted to do something that was like weird and esoteric. I had this dream of becoming like a real scientist working, late at night on important problems and making progress. And so I thought the key thing was to work on something that sounded cool and difficult. And then I tried high energy physics, but basically I felt like I was running up against like maybe that wasn't for me because it was just too hard mathematically.
Okay.
And then I was like, what can I find that sounds as cool as high energy?
But this
Because
is like in
theoretical high
your, this is
energy.
before your pitch, right?
Yeah. This is like when I was like a bachelor
Yeah,
student or something.
yeah. Okay.
And then I guess like what I gravitated toward was like physics of complex systems. Like that's more manageable. Like
Yeah.
yeah, I can do the math and I guess I could also do the other math, but I couldn't be creative in it. Like that's what I felt. I felt like I needed a place where I could be creative. And so
Mm-hmm.
I gravitated toward the physics of complex systems. And then like as I was progressing towards my thesis, master's thesis, I I found out about networks. I found the early papers from Newman,
Mm-hmm.
and it was just super exciting that he was taking these network science data sets
Mm-hmm.
and then beginning to analyze them and do a kind of physics of new stuff in the world, right?
Yeah. So it was like around 2005 or something.
Yeah, even earlier, like
Okay.
2003, I think I handed in maybe even before.
Mm-hmm.
No, something like 2003,
Okay.
2004, maybe.
And now you're basically working on social media. So I have two questions. One is that what does social media provide as a research opportunity? And another question is that how do you really deal with social media? Do you just study it or do you also spend a lot of time on it? Because if you want to really study something, you have to spend some time with that. But at the same time, social media is not something that a lot of scientists really want to spend time on them because it's addictive and it comes with so many problems for people.
Yeah, so I guess I disagree that I study social media.
Uh-huh.
I feel like what I study is human behavior through the lens of data.
Yes.
And one data source that I looked at for some time, but not that much, was social media.
Mm-hmm.
So if you think about the work that I've done recently, a lot of it has been with mobility data from GPS, let's say. I've Most of the work that I do now is based on registry data. Um, and I've worked a lot also on sleep patterns,
Mm-hmm.
and none of this has to do with social media. So it's true that I worked on some data sets from Twitter,
Mm-hmm.
but that was also in a way because that was a really, really interesting data source about people. And especially in the beginning of Twitter when it wasn't so locked down, you could say.
Okay, so but what is your relationship with social media? Are you active on them, or do you feel that it's something cool to use, or have you changed your attitude recently?
So, I mean,
The,
I changed my attitude a long time ago.
okay.
So I think very early on, I kind of began to think that Twitter was like a fantastic place
Yes.
for finding new information, for connecting with people that you know from far away. And like pretty soon I I began to have what I would now call like a somewhat unhealthy
Yeah.
use of Twitter specifically. I was
Okay.
never like heavy user of any other platform. Um, and for many years, I used it just nonstop. I would like wake up and check Twitter, something like this.
Mm-hmm.
And then at one point, I realized that maybe it wasn't the healthiest thing for me. And also that Twitter had changed so that it felt much more boring.
Yeah.
That I had this feeling that Twitter was kind of just the same people saying the same things
Yes.
all the time, a little bit like the kind of the scroll on CNN that's
Mm-hmm.
there at the bottom of the screen,
Yeah. Yes.
the chyrons,
Yeah.
and so I worked hard to cut down on my use of Twitter,
Mm-hmm.
and it worked for a while, and then I would backslide, and then I would cut down, and it worked for a while, and then I would backslide, and so that was like a pattern that kept repeating itself until I was saved by Elon Musk, who took over and made it so horrible to be there that
Yes.
I now no longer use Twitter
Yeah.
at all.
Okay. But do you think it will also affect the way that we gather data or get data from? Because like I always have this problem that when we are in this computational social science bubble, we talk about society, but we basically are talking about how people behave on some platform. It's not really
Yeah,
people.
sure.
And now it's getting harder to get enough data. And a lot of people believe because of bots and a lot of other stuff that social media is now, the data is getting much more untrustable, maybe, or something.
Yes.
And with this new changing, will you saying that in 5 year time, still these data sets are good, or can we find interesting problems to work on as researchers who are not affiliated with the platform?
Yeah. So, I mean, you know, I did an experiment many years ago, back in
Yeah.
2012,
Yes.
called Sensible DTU, where we
Uh-huh.
bought 1,000 phones
Yes.
and we handed them out to all the freshman students at
Yes.
DTU with the idea of measuring their kind of social networks across many of the communication channels that were available. So
Uh-huh.
the phones, of course, record like when people make phone calls, they record the text messages, they record also when people are close to one another, so you can form networks of physical proximity. And actually, you can also, I mean, you use the phones to
Yes.
access social networks
Mm-hmm.
and so on. So you could also measure how people connect on the social networks.
Yeah.
And my entire motivation for running that study was exactly what you're talking about. That basically I felt that a lot of people were looking at data from some
Mm-hmm.
small fraction of all human communication,
Yes.
and um, and they would claim something like, we found out this fundamental thing about how
Mhm.
human beings behave, but actually they had only looked at a small fraction of
Yes.
some human communication.
Mm-hmm.
So my kind of motivation for really running that study was because I wanted to see, well, what happens if we can look across all those channels
Yeah.
and see a kind of more complete picture of the communication.
Yeah.
And
Yeah.
that's a long-winded way of saying that I agree with you that social media is not a good way to say something fundamental about
Yeah.
all human communication. But of course, I think that you can say many meaningful things
Mm-hmm.
about Twitter and about some of the behaviors on Twitter by studying Twitter and so on, right? So it depends on the question, I guess,
Yeah.
is my answer.
Let's circle back to this experience. So something I like about you is that you not only do theoretical type of research, but at some point you come up with these cool ideas that let's do some real experiment in a way that we do gather data the way we want. And it was like a massive scale type of project in a way, right? And
Yes.
also expensive because you had to give a cell phone to every student and wait for like 6 months or 9 months.
It was, I mean, there was like a terrible idea, what I tried to do, and it's
But did it
an
come to
enormous,
you just like out of curiosity, or you really was planning for something like that?
well, it was more that I really thought that there should be a data set like that. And I was annoyed that no one was creating it.
Uh-huh.
And then I thought maybe I actually have kind of
Okay.
the skill set to create it. So maybe I should be the one to do it.
Mm-hmm.
So that was really the motivation, that I wanted to work on the data set.
And how did it go?
Well, so it went in a way, like it went amazingly or whatever. Like it was fantastic, but it was also like an enormous amount of work. It's basically like running a startup, I would say.
Yeah, and then like how many people were involved in that? Is
So there was like 1,000 students with the phones,
uh-huh.
and then we had to have a pretty big technical team to build like also everything was custom. So the whole back end,
Yes.
we had to build, and also just imagine like 1,000 people running into issues, right? So we had to hire like someone to do tech support, and
Yeah.
yeah, it was very big, and it was a kind of and it was also to get the funding. I also needed to start this like very big collaboration with a bunch of social scientists, and that had many positive benefits, because it kind of gave me a crash course into social science, and it gave us depth into kind of people to discuss our analyses with. But it's also, again, like a huge administrative overhead to all of a sudden coordinate like data and working together with all this with all these people.
Yeah.
So it was a massive project.
Do you have any plans for any similar other experience?
No, I would
Experimental?
never do
never
it
do
again.
it again.
Absolutely not.
But
And I think people have tried to do it, and
Yes.
and have had an like enormously difficult time with it.
For
It is
sure.
it's harder than it sounds. Like,
Yes.
I only kind of endeavored to do it because I didn't know what it would imply.
Okay. But you have also been involved in this type of questionnaires, like that you design a list of questions and ask people to reply, or you have
Not
been,
really.
no?
Not really.
Okay. But do you feel that when you're doing that type of experiences, it is like more science because like you're really gathering data from scratch, then you analyze it yourself, and like the whole steps have been done with your team or whatever, but it was your idea and you found a way to find data for it and you finally used it in your research.
No, not at all. I think for me, everything is about having the right data set. For
Yeah.
me, data is at the center. So, like, just to give you some context, I started out as a physicist, and as you could tell, like, I was kind of enamored with the idea of theory, right? I
Yes.
grew up at the Niels Bohr Institute with, thinking about, hang on, like, sorry, my computer is doing something weird. Thinking about, like the history of quantum mechanics, thinking about someone like Dirac, who would like sit in the basement at the Niels Bohr Institute and basically, while everyone else was playing ping pong, he would sit and write down equations about, like relativistic quantum mechanics. He would be like, oh, maybe it looks like there should be a positron. Like, let's go look for it. Or Bose-Einstein condensates, where like they would write down a theoretical idea. And then like many years later, experimentalists would then come and
Confirmed.
and actually run the experiment and say, yeah, it was correct. And so I grew up with this deep love of theoretical physics.
Yes.
And I thought I wanted to be a theoretical person. And the thing that really changed that for me was moving to Laszlo Barbashi's lab in Boston, where I kind of saw the amazing things
So
that
it was your
were.
postdoc after finishing your PhD
Yeah,
here in
after I
Denmark.
finished my PhD, I did a postdoc with Laszlo Barbashi. He had just moved to Northeastern University after some years at Notre Dame,
Yeah.
and working in the kind of alongside Laszlo and in that group really changed my whole perspective.
Mm-hmm.
And firstly, I could see like all the amazing stuff that Laszlo was doing with data.
Uh-huh.
He was writing some wild and kind of important papers then about the limits of predictability and human mobility. So some of the kind of key papers
Uh-huh.
that he was known for, and I could really see the power and things that people could discover in the data, that they were doing a kind of physics but of data sets, that they were kind of finding the patterns. I'm like a little bit careful not to say like the laws of
Yes, yes,
laws
yes.
that are happening, but like the patterns that are kind of inherent in the data sets. And I think that it really shaped, like thinking about this and reflecting, like why were their results so much more interesting than the kind of theory that I was attempting to do. And to be honest, like the thing that I think is the case is that the science of describing, let's say, human activity is not
Mm-hmm.
really ready for any theoretical work, period. So the theory that comes out are like cute small models that are really not useful for very much. So
Mm-hmm.
so that the amount of theoretical work that is actually exciting and
Yes.
not just like a cute toy model
Yes.
is incredibly limited. And then I was like, so maybe it's time to embrace this data stuff.
Uh-huh.
So I think that, quantum mechanics didn't arise without data. Like quantum mechanics came because there had been like a long period of people running experiments, saying, what happens if we like shoot particles at this tinfoil?
Yes.
And they would like shoot particles at tinfoil and they would expect one thing and then like something crazy would happen, right? That most of them would pass through and then some of them would like scatter back in like all different directions. And like, what can even happen? So quantum mechanics didn't arise until there was really kind of an enormous data set that was enough to begin to form a theory that in some way captured something fundamental that's going on. And I honestly think that in like the science of describing human behavior, we are still at this kind of pre-theory
Uh-huh.
time. And for that reason, I think the most meaningful thing someone can do is work on data. And so what I am passionate about is kind of finding interesting data sets. And maybe sometimes I will create them myself,
Yeah.
but that's not what's crucial. What's
Yes.
crucial for me is that there is a data set that holds the possibility of telling us something exciting.
Okay. Okay. Now I have two questions. One is the very trivial question that one would ask then, what's the difference between you and someone who is like generally a data scientist? Because apparently, because the thing is like when you're talking about physics, well, we have had centuries of well-defined theories and well-defined approaches and like to what we observe, and
Yes.
there is a culture of how to design these spherical models and then try to understand the universe. So,
Yes.
despite it was a new data, a new experiment, uh, it was still in this mainstream of physics. But the problems that you're working on, if you look from like far away, they look to be all around the place. Like they can be in disciplines that are not in the mainstreams of physics or even mathematics or like anywhere. It can be a
Yes.
very general question. So how you as someone who was trained to be a physicist are not doing this research? Because any other person who is good with data or anyone who is curious enough can still be on this project. My whole question is that does physics give you an edge, or is it just like, no, it happened that you are now here?
No, I think physics, I don't know if it gives me an edge, but it makes me do something different than a lot of other people.
difference
So,
in
so,
both
so,
ways.
so, like, let's take our kind of social science friends.
Yes.
Like the way that they tend to work, if I can caricature it a little bit, is that they have some kind of theory that typically was like someone came up with it and that said that the thing we think is going on in society is that um, you know um, these 10 things impact how prices fluctuate or whatever
Mhm.
based on some like theoretical results, and that could either be like some economics that's someone
Mhm.
wrote down some equations, or it could be that some old man wrote down like an idea of maybe this is how it'll work. And
Yeah.
then they're like, okay, now I want to test my theory. So I'm going to go find a data set. And then I'm going to look in the data set for like things that kind of correspond to the variables in my theory.
Mhm.
Okay. And then there's a saying, okay, so this thing is like a proxy for this one thing that I care about. This other thing is a proxy for this other thing that I care about. And they kind of try and find, data for each of their variables, and then they can test if the theory works. That if you now put it together the way that the theory says, then you have a model. And this is kind of like the social science
Yeah.
approach. And my approach is a different one, and this is why I call it like the physics of data sets, right? and
Mhm.
and so what I think is interesting is to say, let's look at the data set the way that a physicist would look at the world.
Mhm.
And so I think that one of the key things that happens in physics is that we work hard to identify which variables actually matter, right? So my story
Mhm.
would be like, what's amazing about Newton, of course, is that he could write down, um, like a kind of calculus and develop calculus. And
Yeah.
that's like pretty great accomplishment. But what's more of an accomplishment is that he was able to look out into the natural world
Mhm.
and look at all the colors and all the trees and the
Yeah.
leaves on the trees and the birds flying around. And then you could say, well, the thing that matters here, thing that's interesting to look at if you want to describe the motion of any object, is just mass and acceleration. So like you take the whole complexity of the world around you and you figure out like, oh, the thing that matters, if we want to describe
Yeah.
the write down equations of motion, is just mass and acceleration, and everything else is kind of not important for that. So
Yes.
so he finds the kind of perspective that's the interesting one. And this is what and I'm not comparing myself to Newton, just to be clear. Like I don't, but the idea that I think is interesting is to look at a data set and then find out what are the variables that we can put together that may not be like how the data set was measured. What are the variables that we can identify that do something interesting and that interact in interesting ways with other variables? I think that's what a lot of my work is about.
Okay. So the thing is like that. We use this notion of a complex system versus a simple system.
Yes.
And what basically, so okay, Newton was a giant. I mean, everyone can agree. But the thing is like that in physics, and basically, we all have this luxury of having very careful experiment. So we can control every parameters and measure what we are really interested.
Yes.
Then we have this, like, let's say, imagine we have this very chaotic system like weather.
Mm-hmm.
It's hard to predict for sure, it's hard to model, but the thing is like that if we say that tomorrow it will be rainy with this chance, the weather is not going to decide that now that you said that I will be rainy, I will be sunny tomorrow, because there is no loop of feedback,
Feedback.
right?
Sure.
But in complex system, it's different. So like when you're talking about the society and looking about data and come to this conclusion that yes, this specific pattern, this specific variable is important, it's much harder to repeat the project in a way that go to another country, run the same experience with them and get the result. So what aren't you afraid that when you're working on these situations, you are not just overfitting, underfitting because of a very spatial data set that you're working with? It's not like CERN that we do like tons of experience and repeat and repeat and repeat. Social systems and social data are like small. and it's very hard to get a theory of that. And I'm still like, so what gives you, like, what makes it different from a physicist's point of view in a way that how much uncertainty you can put in your model?
Yeah. So, I mean, so first of all, I'm just noting that you're not commenting on my explanation of what makes my approach different from the data science, but you're moving on to a new problem. So now we're talking about a new problem, and that's fine with me. I just want to
No,
know
no, no. I
that.
mean, given your
Uh,
perspective,
yeah, yeah,
how do you deal with that? Because in social science or
yes.
in the bulk of humanities, they do not start with data usually. They start with general ideas, I would
Yes.
say. But in physics, the problem is that whenever you're making a claim, that claim should be easy to test. But in social system, usually it's not.
I don't know if that's true. I mean, I think so, you know, so now we're coming back to your question, um, which is a kind of new direction here. And so I think, first of all, that like on the feedback thing that you bring
Yes.
up, I don't think that's a massive problem.
Mm-hmm.
I think, like, of course, you can imagine that if I really wrote down like a powerful explanation of, let's say, the stock market, and we published it and it really works, of course, like the stock market would incorporate that explanation and then become kind of unpredictable again. So it's an effect that happens but for many of the phenomena that we study, like, I don't think that they have such massive societal impact that
Yes.
they go feedback and change society.
Mm-hmm.
Maybe on some very few topics with algorithms and so on. So let's table like the feedback part of
Okay.
it and just think about the generalizability part of it.
Mm-hmm.
And so there, I think that of course we can't build theories of human beings that are like the theories of physics,
Mm-hmm.
because the laws are just not as strict, and because there's free will involved and there are many other things involved. But I do think that there's a lot of things that go on that have to do with, let's say, physical limitations. Like, there's a limit to how fast we can move. There's a limit to how many things we can keep in working memory at a
Yes.
time. Like, human beings are definitely are like, in a very systematic way, biological beings that have like limits to how they interact with the world and how they process information and so on. And I think that those limitations can give rise to basically patterns and laws that we can discover that are highly meaningful. And if it is something that's about being human, I think it's plausible that it can also generalize across, let's say, cultures.
I see.
But we could, of course, also find lots of things that are not, that don't generalize across cultures and are specific to certain cultures. And those things can also be interesting.
Yeah.
And I think that, if you think about physics, like, you also start with some data, you start with some experiment, you start with some observation of the world, and you look at it and study it to form an intuition about what is it that I want to, what is it that I want to describe, what's important here. And then as you realize something new is going on, that's exciting in itself. And you could write a physics paper about that.
Yes.
And then later on, of course, if you want to confirm it, then you have to run some more experiments and understand it more deeply. But I do think that there is a strong analogy.
Okay. So now imagine there is this high school student who is basically having this basic physics course, F equals ma, and conservation of momentum and everything. And then suddenly he sees this video that there is this guy who is a professor of physics and working on social science, and that's cool. And they want to do what you're doing. So how do you think that people from physics at the moment can come to what you're doing? Is it a change of mindset, or is it my general question is that if I'm studying physics in university in bachelor's, it's much easier to go to high energy physics because the curriculum is designed to give you the tools, to give you the perspective. But what you're doing, you need a lot of new tools in terms of techniques or perspectives of doing research. And usually in most universities, at least in places that they do not have a branch of complex systems or this type of thing, it's very hard for a student to really get to know how this type of research is done. So if someone wants to be you in a way that do the type of research you want to do you think which part is the most essential part? Like learning how to program, I don't know, learning about networks, learning about, especially because these things are changing a
Yeah,
lot.
yeah. So, I mean, I think that, you can ask the questions, why are there physicists in so many different fields, right?
Yes.
And I think that part of the answer is that physics really teaches you not to be afraid of math,
Mm-hmm.
right? That in physics, like we go through so many mathematical frameworks that you start out and you're like, okay, I have to learn classical mechanics.
Yeah.
So I have to be really good at differential equations and I have to be able to write down this thing. And then they're like, okay, but now next year we're going to do electromagnetism, right? And then all of a sudden you're just like, oh, fuck, like now, sorry for cursing. Oh, darn, you can cut this out. Like now I have to learn like this whole vector calculus
Yes.
stuff, right? And you're like,
Yeah.
oh, curl and
Yeah.
divergence, and you're doing spatial integrals, and like your brain is falling out. And then you're like, oh, and by the way, like now let's do quantum mechanics. And like once again, it's like a whole new framework. All
Yeah.
of a sudden, you have operators, you have group theory, you have all this different stuff. And so I think that at a certain point, and then and if you get to, statistical physics, there's like a whole other framework that's amazing. And so I think at some point, like you see the next year's textbook and you realize like I don't know any of this, but because of what you experienced, you're comfortable that you can probably learn it. Right?
Mm-hmm.
Like in the beginning, when you see next year's textbook, you're like, "What? This is going to be terrible."
Yeah.
But so by going through this process many times, I think that you learn that a new mathematical formalism is not something to be afraid of. And I think that's a key tool to be flexible.
Yeah.
That if someone says, "Oh, we have like a new deep learning algorithm," you think like, "All right, well, I can sit down and figure out what's going on, and I can form my own notion of it." And I think very few other fields are like that. I think
Yeah.
most other fields, even if they're advanced in math, they have like one key framework that you have to be
Mm-hmm.
great at. And so that gives you a kind of flexibility. And I think that
Yes.
flexibility is super valuable. And then I think that there is also a kind of approach to thinking about the world that's
Mm-hmm.
also useful. But of course, you should also learn to be humble. And that's like what you don't learn as a physicist. So I
Uh-huh.
think like humility is probably like the best tool
Mm-hmm.
as you move out of physics to other
Yeah. Yeah.
fields.
Okay. So the way
I
I,
learned that very late, by the way. Like
uh-huh. And how did it happen? You learned it in a hard way or what? Like,
I learned it over time, I think. I learned it by seeing that actually many of the fields that I thought were only, let's say, concerned with details that weren't so important, actually some of those details really were important.
yeah.
And I think that there's a
And
lot.
and just to clarify here, so like being humble, it doesn't just mean that it's just more of being open to other disciplines and other questions,
Yeah, it's to
right?
think that you're not right all the time.
Exactly.
Yeah,
Like
that's the humble.
leave some room for other things. But wait, you, there is something that when you're in a physics department, you may hear it, especially in the more old school people. You may hear that what you're doing is not serious work. Okay, this is one thing. And they may argue that, for example, you guys who are doing complex system, you're not really good in physics or mathematics. That's why you are doing it.
Yes.
And that's not something I believe. Like if we are doing it, it's usually because we like it or we find it more interesting, not because it's easier.
Yeah.
But because of being humble, a lot of people I know in complex systems, they start with saying very similar thing that you said earlier, that I found that I'm not really that good at mathematics, or I couldn't be creative enough in this type of project. That's why I moved on. But it's not like that you couldn't pass your calculus course or
No,
advanced
no.
mathematics, right?
No. But I think, for example, working on like general relativity, I found that I was struggling to keep up with the formalism much more than was like, and maybe I could have caught up, but I felt that it was hard enough just to learn it.
Yes.
And like coming up with new ideas in
Mm-hmm.
that world was not something that I felt that I was super good at.
Yeah, and
Do you know
then
what I mean?
I would say, yeah, yeah, for sure. I mean, like every person has a different taste, and it is a matter of taste, not like because I'm not generally good at something, that's why I'm doing the other thing. Because I believe this humbleness of people around us sometimes make other people take advantage of it and call us that we are not as good as they are,
But I
right?
don't care. I don't care about that. I do. I honestly think like I talked about the kind of discovery of how crucial it is to look at empirical data rather than theory from being at Laszlo's lab.
Yes.
And I think another thing that I also learned is that the kind of doing important work that
Yeah.
like leaves a mark on science and that people care about is like quite uncorrelated with um like raw
Mm-hmm.
ability to
Yeah.
write down like hard equations.
Mm-hmm.
So like like if you are amazing at hardcore math, but what you do is boring and no one cares about it, then like so what? Like in a way, for me, it's
Mm-hmm.
exciting to try and do work that also people care about.
Mm-hmm.
And I
Okay.
think that's less correlated with raw
Yes.
mathematical ability. Uh, of course, it would be nice to have that too, but I don't see that as essential, and I don't see it as a big part of many, many people that I
Mm-hmm.
consider to be insanely brilliant.
Yes. Okay. Now let's talk about it that when you want to do a research project from scratch,
Yes.
what determines that this is a good research project? Is it the idea behind it? Is it the data set? Is it the collaborators? So like, okay, let me say this. I am a I'm a big fan of movies and stories, and I used to think that a good movie should start from having a good screenplay.
Yes.
Then there is this famous Iranian filmmaker Amir Naderi who said, "I never care about the story. I never make a movie unless I know the sound design. I never make a movie unless I know how to edit it." And so he basically, yeah, he is a very interesting guy. He said, like, I want to know everything, and a story is like a wind, is like a breeze. It comes and I catch it.
Yes.
Like, is it for you the same that idea or the research question is like a breeze, or is it like the main thing to begin a project with? Like, just what happens on your daily basis that you say, okay, this is a cool project. What makes it cool to start working on it?
Yeah. So, I mean, the answer to the list of what you say, I think in my experience, it has been all of them. Like sometimes an
Mm-hmm.
idea has been the kind of thing that instigated a project.
Yes.
Sometimes it has been a collaboration that some people have, reached out and said, we're working on this. And so I think that there can be many, many different paths
Mm-hmm.
um, to a paper and to the idea in a paper.
So, for example, can you do a nice project, or do you find a project nice because of a set of collaborators, but the idea is not interesting? Like, or it should always have a minimum of everything, and then something is like making you,
Yeah, but I don't know. Like, it's hard to think of it. Hard to think of it like that. Like, typically, if some people have reached out to collaborate on something, like, or we've decided to start a collaboration around something, there has been like the
yeah,
germ of an idea, or
yeah,
people have reached out already with an idea that I thought this sounds interesting in some way.
yeah,
But maybe the important thing to say is that what makes a great paper is not, you know, like that the ideas should get better and better and better and better and better through the process.
mm-hmm,
It's very rarely that I've found, like an amazing idea and then it's just carried through the whole thing. That's also happened like a few times, but
mm-hmm,
a lot of times you start out with like an idea that's pretty good and then it gets more and more exciting as you work on it more and
yeah,
more and you kind of get at what is the thing really, right? And that's also I think an artifact of working with data
mm-hmm,
that um, nature is so much more interesting than what we can come up with in
Yeah.
our brains. So like when you work hard at trying to understand a problem that's out there in nature
Mm-hmm.
or in a data set, that's often a lot more exciting than something that you can come up with. Like you can make
Sure.
discoveries.
Yeah, yeah. But like imagine one of your PhD students come to you and say, "Hey, Suna, I have this idea. Should we start writing a paper on it?" Uh, How do you then go through the process? Like you listen to him or her and then say, "Okay, it sounds cool." And then you start realizing, okay, but it has some challenges. One challenge is like, for example, we do not have proper data to test it. Or do you think that no, this question is well so general and it's not worth doing it? And sometimes I know it's so like when someone who is like not senior enough or not experienced enough, who is not careful with phrasing the question comes to you, how do you treat that? How do you react to a question which you are not even sure that a student is capable of really doing it the way that you would do it on your own?
Yeah. All right. But so, I mean, in some sense, it is like the wind, right? Like
Yeah,
in some sense, there is this idea that is it exciting? Is it
yeah,
exciting to me? That is also underlying somewhere. Like so, if someone comes to me, I would also always try and be open and try and listen
mm-hmm,
and try and understand, right? And then you're totally right that I would run through some kind of checklist saying like, that's great, but like we couldn't do it. Like maybe I thought about it before,
yeah,
or something in that direction. That's often the case because I spend so much time
mm-hmm,
working on some of these topics. And I just know that it like
mm-hmm,
that there's not a good data set, and then I can explain like, but think about how would you do it, and we could talk about it. Maybe they have a great idea
mm-hmm,
for how it could be done anyway, or whatever. So there is definitely the idea that I would think through, like the practicalities and can it be done, and but I think at the end of the day, of course, what a key question is like, if it could be done, would it be interesting? And I think that
mm-hmm,
part is like some kind of
mm-hmm.
intuition for,
Is it worth doing it?
yeah, like
Yeah,
how exciting is it?
mm-hmm,
And I
mm-hmm,
think like we all have that
yeah,
to some degree. Like in the end, like if someone says, like I had this little idea and it's like it could probably be a paper, and it would probably be like a pretty easy paper, then I would often say, but is it really exciting? Because no paper
yes.
is easy, right? Like, so you should only do papers where you go like, this is amazing. Because at the end of the day, like whatever easy paper you would write with like a small or boring finding will be like
Yeah,
still a huge amount of work.
but what does it mean that it's amazing? Because like amazing, it's like a subjective thing, right?
Yeah, it's like
And
beauty in art or whatever. Like
yeah,
I
so
know it
like
when I
that,
see it. It's like the wind.
yeah,
Yeah.
exactly. So like, then do you think that you can teach it to people? Like, so when you say it is amazing, I mean, and I'm in the same meeting and I say, well, I didn't find it amazing. And then I go home and I start thinking, why soon I said this amazing? Do you think like these things can be taught to people that like under or appreciating the beauty in a research question? Or having a good taste in choosing the right question.
Yeah, I think it can be taught. I think
Ha,
but it's like how do you learn to appreciate good food, or how do you learn to appreciate
yeah,
music or whatever? Like you eat a lot, you pay attention, and
yeah.
you discuss it a lot, and like over time you can build up some kind of intuition, right?
So when you look at your people that you have been working as a mentor, do you
Yes.
believe that you can see that the taste of these people has changed over time? Or do you always care that how much you could influence their taste?
Well, so I don't think that it's necessarily a good idea to influence people's
Uh-huh.
taste because people are also very, very different,
Yes.
right? And I think that a terrible strategy would be to think like I want to be like Sune. You know what I mean?
Uh-huh.
It's like if you want to
Yes.
be a rock star, you shouldn't think like I want to be
Yes, Sune
like
is already taken.
I want to be like Mick Jagger. Like that's like you should figure out who you are,
Yeah.
and you should figure out like what is the thing that you do that's different from what everyone else can do, and you should go after that. I mean, like, so emulating kind of my strategy
Mm-hmm.
is not is probably like a terrible strategy for many other people. So I think it's more it's more about as like as you become your own researcher, it's about figuring out what is it that you can do that's amazing that very few other people can do. And I think like this is also a process that I went through. Like at some point, you know, I also thought that I needed to do certain things or wanted to be certain things until I realized like it's way better to kind of figure out what is it that I'm pretty good at. And in my case, probably it is identifying like stuff uh, that's interesting or
Mm-hmm.
identifying good ideas to some degree,
Mm-hmm.
uh, and and draw on that rather than try and be all kinds of other things.
Yeah. Okay. So let's say you are having some master's student,
Mhm.
and master's student are usually so busy with other courses, and they come to you and say, "Hey, we want to do a project,"
Yes.
right? And these people have a different interaction than like PhD student with you because you get to talk more with your PhD student,
Mhm.
and little by little through different conversation, basically you train people, right? And
Yes.
that is something that a lot of places people say, yeah. I mean, back in time that people were not that sensitive about using the phrase PhD student. These days, everyone is caring to say PhD researchers. They are not.
Yeah, sure.
I mean, forgetting about that, the thing is like that a lot of time you can see that some institutes they build a school of thought. It's
Yes.
not necessarily engineering people's brain, but for example you can say that
Sure.
from Sapienza this statistical physicist came, that Giorgio Parisi was the head, and then blah blah blah.
Yeah, yeah, yeah.
So do you even think that you're going for it, or
I mean, I think at
because,
least to
because you
the
just, for example, mentioned Laszlo, that being in Laszlo's environment and around him and in his
yeah,
team, you got this inspiration or idea of doing this
yes,
type of research, right?
yes. But I do think that I have some things that I try and impart, but they're not so much related to the idea generation process. I
Mm-hmm.
think that the thing that I want to impart to to everyone is related to a kind of attitude to the work that it's
Yeah.
worthwhile doing the best possible work that you can do.
Mm-hmm.
Like that you shouldn't try and do something that's like a little bit good.
Yeah.
Like if we're here and doing this, we might as well try and create work that's truly outstanding. And that
Yes.
means kind of paying attention to every single detail and making it as good as we can make it. I think that's like a key thing that I try and teach people, but that's more about process and attitude than about, like the specific idea. I think it's also important to me
Mm-hmm.
that I want to impart lessons around being a good person, about treating people with
Yes.
respect. And I
Yes.
think it's a good investment in science. Like I
Yes.
think it's not just so that to generally be generous and kind,
Mm-hmm.
friendly and helpful to people is
Mm-hmm.
another thing that I think would be
Yes.
like super important
Yes.
in a scientist, because only through collaboration can we I think at least collaboration is such a crucial part of many of the things that we do, that this is like a great thing to learn, right? I don't want to teach people
Okay.
to and so on. So there are a lot of things that I think are important, but I don't think that the kind of that I have, like my experience with ideas and where they come from is that it's so different and random that that's a thing that I don't know how to teach. But there are some things that I think I do know how to teach.
Yeah.
And also like ambition, like
Uh-huh.
not just quality, but also to aim high.
Yes.
Like try and do something that's amazing, not just in terms of the quality of it, but also that like you should like hope to put it in the best journals and so on.
Yes.
Like that's like, because without, it's not a guarantee that you'll succeed, but without trying, like for sure you won't succeed, right?
Yeah. Yeah. Have you ever unlearned something?
Being on social media.
No, but in a way that sometimes you get so attached to some idea or a strategy or way of conducting a research or anything in
Well,
your
like
professional career?
so I think I unlearned the idea of like loving theory, for example. Like I
Hmm.
told you, like I think that was a thing where I thought I wanted to be one kind of scientist, and then I really saw no, actually, here's another path that's way more exciting to me.
Yes. But in your private time, do you still have a huge love for theoretical physicists like Einstein or these people as like your heroes? Because you have online theory, like, do you still have them as
Yeah, like
the
I think theory in a way still is kind of like the highest, most elegant thing that
okay?
you can do. It's just that I don't think that the field in which I'm working is ready for that kind of theory.
Yeah,
And maybe it will
it's
never be.
as valuable as that, right?
What's as valuable as what?
No, I mean, I mean, you do not feel that the theories, theoretical scientists are superior to.
No,
Okay,
no. But what I'm saying is that, but I do think that
because it takes
as
a
a
lot of
beautiful,
time for people to detach themselves from
yeah,
this
yeah,
type
yeah.
of thoughts.
But I mean, like, yeah, I think like now I don't place that kind of value
Yeah,
on
right.
anything in a
Okay,
way.
yes.
Like now I'm much more just interested in filling my days with things that are delightful somehow,
Okay,
right?
okay. I want to finish, but let's talk about your research group. You have almost moderate in terms of number of people working with you.
Yes,
And as far as I know, you spend enough time with people, you have one-to-one meetings, and you try to not have many people in your group because
yes.
I believe it's a matter of how you control the time and scheduling everything.
Yeah, I mean, it's basically like a very simple explanation is that, like I said, I really try and fill my life with things that bring me joy and that I find
Yes.
delightful. And what I like more than anything is collaborating with people on science.
Yes.
And I find that if my group grows very big, then I go from being a collaborator to being a kind of administrator. Like I
Mm-hmm.
become the person who just writes emails
Yes.
on all day. And
Mm-hmm.
I'm not interested in that because even though that comes with some kind of advantages from the outside, it's not what I want. Like I want to be involved. That's what is fun and exciting to me.
Do you still code yourself
I mean, these
or
days,
work on pen and paper calculations?
to be honest, like I mostly do it now when teaching,
Mm-hmm.
because in teaching, like I have to come up with new problems and I have to do new things for the students to solve and so on. So, in being a teacher, I still code and write down equations and stuff. But most of the time, I do that through the people that I work with. So it has been a long time since I wrote code that went in a paper.
Okay. Okay, I see. So to close, I like you to think about it in a way that you want to give some bullet point advice to different people, people who are doing the undergrad, people who are doing the graduate level courses in complex system, people who are doing a PhD in complex systems, and early career researcher like postdocs and like very young. If you want to come up with something to tell these people, what would you say? And we can start with undergrads or early career. Which one
Yeah.
you feel
Okay.
more ready to go for?
Yeah. Maybe I can start with a story and then we can circle back. So I remember when I got my first grant from the Vilum Foundation. So like a big kind of starting grant, some it's like more than $1 million US dollars.
So was it when you were already a faculty member?
I had just become an assistant professor,
Okay.
but I actually wasn't like I wasn't didn't have a permanent position.
Yes.
And the grant actually gave me a permanent position because they would only give me the money if I had a permanent position. And so it helped me negotiate like getting a kind of it's not really tenure in Denmark, but getting a permanent position. And so after getting that grant, I was at a meeting that had all the grantees, so all the people that have been awarded money from this funding agency over the last 10 years. So there was a lot of money in the room. Like you can imagine, this
Yes.
corresponded to maybe them handing out something like 700 million Danish kroner or something. Like all those people were sitting in one big room, all the
Yeah.
people that they had given money to, and then they kind of had like a retrospective. And then they have a guy come out, give a talk who was like a big researcher. And he said the following. He said, like, when you get your funding, you have to go from being the very best in your field at doing research
Mm-hmm.
to becoming a research manager. All right. So you go from being like, when you're a postdoc, you're basically like top of the game. You can write great papers. You know how to work really hard. Um, and then all of a sudden, now you have the responsibility for students and postdocs. And your main job is not to do excellent research anymore. It's actually to help
Mm-hmm.
other people do excellent research.
Mm-hmm.
And I was like, what? Is that really true? And then I thought about it. And actually, in a way, it is true, right? That
Mm-hmm.
when you start a group, something really wild happens. That you go from kind of being responsible for you doing amazing research, coding yourself, as you
Yeah.
were saying, to not doing that anymore, to doing something different, to trusting other people to do the work. And it's not an easy transition. And if you think about kind of the wastefulness of this, because it's not a given that someone who's amazing at doing research on their own
Mm-hmm.
is amazing at running a research group.
Mm-hmm.
In fact, like you could even argue that those qualities are probably like not typically in the same person. So
Yeah.
science, in a way, is like this incredible uh, wasteful process that's about
Yeah.
identifying people that are both good at being the individual person
Yes.
doing the work, and then can convert to becoming like a good research manager who
Mm-hmm.
is basically the mentor and helper of a bunch of other people.
Yes.
All right. And
And
so
there is no training for those transition times.
no, and basically they have to hand out like $1 million
Yes.
to every single person they think could maybe do it.
Yes.
And then like some of them will succeed and some will fail. And like
Mm.
that's how you find like the next generation of scientists.
Ah,
And
yes.
it's a wild thing,
Mm-hmm.
right? Um, and so I'm telling the story because I think that that it makes sense to say that I like, to me, like the best advice is, like I said before, that try and pay attention and figure out what your own strengths are and then lean into those. I think that's like the main thing, right? So
But this is
whatever,
for undergrad people,
no, but so this is like for everyone.
everyone.
Yeah. And be and be aware that uh that um whatever you focus on, well, I mean, I guess I think this is for
Mm-hmm.
everything, but you're asking me to give advice, and I think this thing about being yourself and figuring out, like, I can tell you another story, like, for this, like, I have a former student called Piotr who was brilliant, and as a student, he was suffering so much because he would basically do an amazing job at working on a paper, and when he was almost done, he would think like, I realized like a flaw in my thinking. So like I want to like redo everything and
From
start
scratch.
over and do it again. And then he
Okay.
would do it again better. And then he'd be like, but I realized like a flaw in my thinking. And I'm not even sure that
Mm-hmm.
we can't even publish this paper. And I would say, dude, it's like a tiny flaw. We can write that, here's a
Yeah.
potential issue. And he would want to like redo the paper again. So he could never finish anything because he
Yeah.
was so good at finding flaws and criticizing
Yes.
criticizing himself that it was hard for him to finish anything. And he
Mm-hmm.
really had kind of, and he felt that he lived, I think, I mean, I'm not, like he should chime in on this, but I think that he felt that he was kind of cursed by this ability to see flaws. But now he is like incredibly successful at finding flaws. Like he's auditing algorithms, and he's doing this insanely important work at trying to understand how the big Facebook algorithms work and how all these
Yeah,
algorithms work. And he's
I'm
doing
just
this.
imagining having him as your reviewer, your
Good luck.
It's gonna be tough.
Yeah. But so now like he found kind of a place of working where like what he thought was his big flaw is his superpower and
Mm,
where he's thriving, right? Does that
I
make
see.
sense?
Yes.
And he's doing amazing work and he's helping the world, right? With this
Ability.
superpower.
Yeah.
And so I think like this idea of figuring out what is it that is my thing that I can do, that's like my advice, my general advice at
Mm,
every stage.
yes.
Then coming back to now so I just needed to get that out because I think it's like the most important thing basically.
Mm-hmm.
Now to get to the career stages, right? What this means is that in all the early career stages, of course, what you should do in a way is try and be like the best possible uh, version of an insanely good researcher that you can be. Basically, until you become a postdoc, you want to try and focus all of your attention into writing papers that are really good and amazing, right? Ambitious, like I
Yeah.
talked about, and that are thorough and that people have to reckon with. That when people see that paper, they think this paper is written by someone who is an amazing researcher.
Mm-hmm.
I think that's what you want to aim for
Yeah.
at all of this. Uh, and then, that should be your main priority. But at the same time, it also makes sense to try and be a whole human being because, at some point at the end of this, like you won't just be writing like intensely focused papers, but you will also be a manager. So it makes sense to, like you're doing, you love movies, you have many hobbies, and I think to be a well-rounded person is also someone who, through consuming culture and doing many other things, can have empathy and understand people better,
Mm.
and to be, a good person. Like the other thing
Okay.
that I try and impart, right? So I guess like my
Yes.
advice is just the same advice that I give to my students, which is try and do awesome work and try and be a kind and generous person. I think those are my key.
Mm-hmm.
That's what I'm working on still. you
Well,
know?
yeah, I mean, I appreciate it as it is the missing piece of puzzle in the world, not just in academia, being nice and
Yeah. I
open.
think it's a good strategy.
Yeah.
It feels good too.
Yes.
Yes.
Yes. I guess we've almost covered everything that we wanted to talk about, and I'm looking at the questions. Basically, uh, I have asked you what I was asking, except this one little question. Circling back to social media, some
Yeah.
people argue that because of the whole environment of borrowing or robbing your attention, the young generation of researchers or young generation of students, they cannot really finish reading a book because basically, thanks to TikTok videos and shorts on YouTube or very small chunks of information that we keep scrolling, people are growing this bad habit that they cannot really be focused and concentrated on a subject. Do
Yes.
you think it's really a thing? And do you think it's gonna harm the future of science and scientists? Because in science, you need to be focused.
Yeah, yeah, yeah. Well, I mean, so first of all, I would say that it's not a problem for everyone because I I see many brilliant young people that don't seem
Yeah.
to have this issue, right?
Yeah.
But it could be a problem for some people.
Mm-hmm.
And I think in general, I do think that it's something to be mindful of. This thing that to to be able to focus and to be able to go deep and
Mm-hmm.
be able to do something different, right? Like one of the things I was saying about social media earlier in our talk was this thing that you know, we when we're on social media, we just see the same things repeated again and again. And in a way, what we're supposed to as scientists is to come up with ideas that are new and different.
Yes.
So like by being everyone being exposed to the same media diet, like it's clear that there's a homogenization
Mm-hmm.
of ideas, that everyone is working on the same problems, doing all the same things. And in a way, like I think that it can be much more interesting to read some books and read some old books and go in some different directions and look for new and exciting places to
Yes.
find the problems.
Mm-hmm.
So I think that's a thing, right? I also think that the large language models are that we're outsourcing are thinking to them more and more.
Mm-hmm.
And I think some instances that can be really good.
Mm-hmm.
But of course, if we do it to the extent that we don't
Yeah.
learn anything, like the kind of the de-skilling
Yes.
idea, of course that can be dangerous. So I think it is something to be mindful of. Um, and I know, like, I don't know how I can make like strong claims about this because it's not really something I'm an expert in, but I can say that I personally
Mm-hmm.
try and not be on social media, but read books because I feel that it helps me.
Yeah.
You know what I mean?
Yes.
And I try to not outsource all my thinking to language models,
Mm-hmm.
but to actually do some of it
Mm-hmm.
myself. And it's a conscious choice that I make for
Yeah.
me. But I don't know if I can be prescriptive because I mean, frankly, I don't have the
Yeah.
evidence.
But like when you are teaching a course here at DTU or other places,
Yes.
so usually when you're teaching not very advanced material, almost all the questions that we give as problem set to people these
Yes.
days, they can be easily solved through even like
Yeah. Yeah. Yeah.
ChatGPT, not even the paid version, right?
Yes.
And when you go to the classroom early sessions, do you talk about these things
Yeah. Yeah.
about
Yeah. I do.
and
So I basically tell the students that, you know, the chatbots are the most amazing thing that ever happened for human learning,
mm-hmm,
that they now have an assistant that can explain everything to them
yes,
if they don't get it with great patience and through a bajillion different examples, and they can spar with it and they can do whatever. And it's amazing. But there's also a tool that can completely undermine their learning, that if they don't do any work themselves, like nothing is going to happen. And I use this analogy of going to the gym and to say, like, of course, you know, it's pretty clear that if you go to the gym with a giant robot
mm-hmm,
and you have the robot do all your squats and deadlifts and bench presses, like nothing is going to happen for you. Like, in order to change, you have to challenge your body. And
yes,
that the brain is something pretty similar. That in order to get your brain to be able to do new things and to do new, like, yeah, to grow and to evolve and to change, then you have to challenge it.
mm-hmm,
And so if they can see the idea
yeah,
about the
yeah,
gym, like hopefully they can also see that in their education they also have
yes,
to do the work. And if they don't do it, they won't learn anything. And then they wasted all the time they spent at
mm-hmm,
university because then they can just be replaced
yeah,
immediately by someone
mm-hmm.
else using a chatbot.
Yeah, but what about your PhD student? Do you give them the same advice in terms of using the chatbots? For example, at least, how do you feel when you're writing a paper with a PhD student and you can feel that all the literature review is done by a chatbot, and you have this idea that, well, people should really read what they write. So,
But I mean, but I don't think that has happened.
mhm,
Like I feel that sometimes my students use the chatbots to improve their writing, let's
yes,
say. Um, and I think that that's okay. But in general, like I know about the literature because we talked about it. Like I know that they know the stuff.
okay.
So
But
there's like another benefit of working closely with the
yes.
students, I guess, is that have a good sense of where they are.
Mm-hmm, mm-hmm. Okay, so but because like basically as a PhD student, it's very different than like a bachelor that you want to pass a course. So you want to use all of these new technologies to do better research,
Yeah.
and this is quite a new thing. Like in your time when you
Yes.
were doing your PhD, this was not available,
No,
right?
no, no.
You can easily now rephrase, rewrite, do literature review, find
Yeah.
caveats in your even reasoning. Sometimes nowadays it's very good to say, hey, what's wrong with this problem? And it's like,
Yeah.
yes, this is the
Absolutely.
problem.
No, but it's changing all the time, and we're becoming more and more obsolete.
Yes.
Every day for sure.
Yeah.
And I think science has to change in response to this. Like I don't know exactly how, but it has to change, right? Like in the end, like if the chatbot can write the literature review, like why do we need the literature review? Do you know what I mean?
Yes.
Like maybe we should just cut it altogether. And
Yeah, maybe it changes.
you know what I mean? Like
But
I don't. This is
yeah,
not a suggestion, but I'm just saying,
yes,
like that in a way, I think that somehow the format of scientific papers and scientific writing
yes.
might have to change somehow.
Yeah, but I also have this feeling that in science we are so slow in a way that most of the templates that we use for writing research papers is still based on that it's gonna be printed on paper and we're gonna read it on
Yeah,
paper.
absolutely.
Nobody's gonna read
Yeah,
it,
sorry.
right? Nobody's reading printed things, or no journal is really getting printed in full, and you get it.
No, absolutely
Yeah.
not. Like we should have interactive visualization, all that
Yes.
kind of stuff for sure.
Yeah. I mean, this is a whole subject on its own, talking about
It's coming out in episode 2 of Abbas and Sune talk about
yeah,
science.
how
Yeah.
science is influenced and it will be reshaped
Yes.
by this. Thank you very much. It was a very nice talk.
Thanks, man. It's good to cover these topics.
Yeah, thank you for your time,
Of
and
course.
thank you for listening.
Thank you.
Yeah, have a nice day.
Have a good one.
Bye bye.